Hi, this is multiple choice question number 18 on the AP Physics C extra credit questions. So here we have an inclined plane problem. We're asked to find acceleration of the planes. Okay, so physics facts that handle inclined planes. We know when we have inclined planes, we have to break it up not into x and y components, although you could do that, it'd just be a bit more complicated, but instead parallel and perpendicular components. And then we need to know, we don't need to have this memorized, we could just by knowing trigonometry, but it's nice to just have memorized. The component of the object's weight parallel to the incline is mg sine theta, making the object slide. And then object's weight perpendicular to the incline is mg cosine theta. Okay, so here for m, so gravity acts straight down. That's weight force. And that's perpendicular. That's our normal force. So what we need to do is we need to break this weight force into components. A vertical component, and a perpendicular component. Okay, so this vertical component, or I'm sorry, I should be saying perpendicular, is mg cosine theta, and parallel is mg sine theta. And it'd be the same for the this one here. The only difference is that there's friction on figure 2. So our FBD will look a little different, and we gotta figure out how it's gonna affect our acceleration. So let's set up just figure 1. FBD, going down, we have mg cosine theta, sine theta. Oh, I'm sorry, this pen is not working too well. And then up we have our normal force. Remember that always acts perpendicular. To the right we have our mg sine theta. And no friction, so we're good in that regard. Okay, so now our FBD for the figure 2 is going to be almost it's going to be almost identical. Only difference is going to be that we have frictional force. That's friction. That's frictional force. Okay, so now we are asked to find acceleration of block 1 and then acceleration block 2 and compare the two accelerations. So we can set up our equations in the parallel and perpendicular directions. So in the figure 1 we have it's just mg sine theta equals ma, and then we have that normal force equals mg cosine theta. Okay. For the right, we have Fn again, mg cosine theta. And then our Newton's second law equation is a little more complex. Mg sine theta minus the normal force equals ma. Minus frictional force. And frictional force, as we know from our physics facts, is mu Fn. So we can solve for figure 1. These m's cancel out. Our acceleration is just g sine theta. That's pretty straightforward. There we go. Here it's a little more complicated. We need to rewrite our frictional force in terms of mu and Fn. So ma equals mg sine theta minus mu mg cosine theta. Okay, so our A, just cross out all the m's. A for figure 2 is g sine theta, g sine theta minus mu g cosine theta. Okay, so A1 over A2 is g sine theta over, we can factor out the g, sine theta minus mu minus, apologies, minus mu cosine theta. Our g's cancel out. We're left with sine theta over sine theta minus mu cosine theta, and that looks exactly like B. Let's just check to be sure. That's the right answer. There you go.